Hello, welcome. Let's have a discussion on the volume of a sphere as one of the episode on main friction 2, the volume of three-dimensional shape. We know a sphere is a three-dimensional shape that is in the form of a circle. We to have, if you want to look at a sphere, you should be having a mental picture of a football. You know, when you take a football as this circle, there will be inner thickness from one corner to another. If you're able to take that, this circle will represent a circle that will have a center. So from here, we are having a radius. And in the same dimension, if I'm to have, okay, let's see. If I'm to have this, you also see that the football, if a line drawn from the top in the same direction, will give us the center to that side to also be a radius. All right, so the radius will be just the center part of it, taking this portion out of that. Now we are going to relate that with a cylinder which has the same radius, or better still, the same diameter as that of the sphere, in such a way that the sphere can easily be fixed into it. If you take a tennis ball and you take a cap, the tennis ball should be able to enter into the cap with its diameter covering it. That is what you're looking for, the same radius. If it's the same radius, then the height of the cylinder should be the same, as in when the tennis ball is placed into the cap, the edge here touching the bottom, this edge will also be at the brim. So if they have the same height, we are aware that from here all the way to this place is going to be the height of this sphere, right? And the height is going to be r plus r. So this gives us 2 of the r. Now, when we fill this sphere with water and transfer the water into this cylinder, it's going to be filling to third. It will not be a complete, when you fix this tennis ball into the cylinder, you can observe that there will be empty spaces. When this is placed into it, it's going to fix like this. The empty spaces, these empty spaces will be also having a space to fill. So that is going to be the 1/3 of what the volume of the cylinder is going to be. So when you transfer the sphere volume into that of the cylinder, it is going to be 2/3 of the cylinder. So if that is the case, it means that we can recall that the volume of a cylinder is given to us from our previous episode. If you are finding the volume, it is pi r square h. That is the volume of a cylinder. Then bringing that connection to this, it means that the volume of a sphere, which we are saying that if you transfer the water into this, it will be forming 2/3 of the volume of the cylinder. Right? 2/3. If this volume is transferred into this, it will be 2/3 of the cylinder. Therefore, knowing the volume of a cylinder, then we can say that volume of sphere is going to be 2/3 times the known volume of a cylinder, which is pi r square h. But in this diagram, you see we have not introduced any h. Our height is 2r. So in place of h, we reduce that. But h is what? 2r, meaning 2 out of 3 times pi r square times 2r. We are replacing the height with 2r. So in that case, I can see r times r squared will be r cubed. 2 will multiply the numerator to give us 4 on 3 pi r cubed. So this becomes the volume of a sphere. If you are taking a sphere, the volume of a sphere is given by 4 out of 3 pi r cubed. All right. Now, we know a cylinder, a sphere, can also be cut into two to have what they call the hemisphere. And we know a hemisphere, let's just say it will look this way, look like a bowl. Just look at this. If we cut the sphere on this, our circular marking, you see that this part will be taken away. This part will look exactly just like that. So this is just like a bowl. And this bowl is half of the sphere. So therefore, the volume of a hemisphere, let me use H, is going to be half of what we have here as 4 on 3 pi r cubed. You know, this 2 is the denominator, this is the numerator. So it will cancel to give us 2 on 3, right? Then pi r cubed. That becomes the volume of a hemisphere. I guess the concept is well explained. How we derive the volume of a sphere and that of a hemisphere. If that is good, come back to this page as we take questions on how to find the volume of a sphere and that of a hemisphere. And the next we will pick will be the surface area, total surface area of a sphere. Thanks for watching. Like, share, and comment. Bye-bye.